If it gets to the end of the list here, then it wants to eject your sample, and there's no easy way to cancel it at this point. Sample. You should set them all up in advance before it gets to the end of the list. Otherwise, you're going to have to do setup again. In this case, we're done, so we can click OK. And we're going to get the dummy sample on the depth gauge. We take out our sample. We put out the dummy sample. Now, even though we're not going to take data on the dummy sample, it's important to put it at the proper height. The reason is if it's too far down, it could hit the bottom when it goes in, and it could break. If it's too far up, it may not make a good air seal on the inside there, and then that's one of the main reasons that samples don't eject properly. So you want to make sure it's at the right height before you put it back, and you want to make sure that you put it back before you go on to the next step. So that's it. We put back our dummy sample, we've taken out our sample, so we can click OK. On the automatic sample changer, you can leave this window open, and you can use the change user button to change from one person to the next. If you're running manually, you should not leave this window open.
それでは出発前のアナウンスをさせていただきます。本日はトラベルインとスキースノーボードツアーにご参加いただき誠にありがとうございます。まず受付時にお渡ししたクーポンですが、こちらは紛失としても再発行できません。ですのでご自身の方で厳重に管理されるようよろしくお願いします。また走行中はシートベルトの着用が義務付けられております。皆様は今一度シートベルトをご着用にされているか、確認いただきよろしく、閉めていらっしゃらないお客様はシートベルトを今一度お閉めになるようよろしくお願いします。ありがとうございます。また、最近忘れ物や紛失物等多くなっております。厳重にご自身の方で、取り間違い等もないように、注意よろしくお願いします。また、停車するターミナルが、2つありますので、その際は、乗務員の方の指示に従って乗り間違い等ないようによろしくお願いします。それではまもなく出発いたします。楽しい時間をお過ごしください。いってらっしゃいませ。
You can use the outward-facing arrows to go back to a full spectrum, and you can close your spectrum without losing your data. It will still be there. If there's a whole lot of experiments open, which there may be if a lot of people are using the instrument, go ahead and close them because too many of them might slow down the program. Okay, so we finished taking our data, we put back the dummy sample, and we've left the instrument in a state that's ready for the next user. We're finished. Is to make sure that the automation is not running. So come to the screen of the automation system and check on this part. Something may be running, and you should make sure that everything is stopped before you go to the next step. In this case, everything's fine, nothing's running. So then we can get to kit for manual injection, which is down here. And we're going to take it over to the magnet and begin setting up the manual injection. Okay, so now we come over to the system and we're going to set up. This thing is to put this under here to collect any of the solvents that drip down as we're flushing various things out of the system. And then we're going to disconnect the line from the automation. So the black line is the input from the automation system and the silver line is the outlet. And then it goes in to probe up to the coil and then back down and out. We're going to disconnect both sides of it. So just unscrew it and try not to drop with the probe too much as you unscrew it. I'm going to set these aside.
走行中の事故防止のためシートベルトを押しの低い位置にしっかりと押してください。リクライニングの倒しになる場合、後ろの方への配慮をお願いいたします。先ほどお渡しいたしましたチケット類は今一度内容をご確認の上、大切に保管し、電気非常にてご利用ください。停車撮影は確保し確認いただき、通り間違いのないようにお気をつけください。また、現地から帰りの際には出発の10分前までにご利用のバス停へご集合いただきますようお願いいたします。出発時刻までにお越しいただけない場合は放置とみなし、バスが出発させていただきますので、あらかじめご了承ください。最近、お客様同士の間違いが多発しております。また、乗の棚、前の座席の紙ポケット、お座席の隙間などを再度ご確認いただき、お財布、携帯電話等のお忘れ物にも十分ご注意ください。車内で出たゴミは当日際必ずお持ち帰りください。なお、このバスには弊社係員は同乗いたしません。
connection goes to the filter. When the filter goes to this adapter, which finally goes to the lure lock connection, which is used for syringe. So the first syringe we're going to put on there is this big one, this 10 milliliter syringe. This one we're just going to use to push out any solvent that's in there with air. When you're using this one, make sure never to draw it up while it's attached to the system, because we don't want to suck solvent back into the syringe. We want to keep the syringe as clean as possible. And this kind of funny thing on the end here is to allow us to push it down and lock it into place.
In case of an accident, please be sure to fasten your seatbelt. Please be mindful of the person behind you when reclining your seat.
I'm going to tighten it down onto the connection, and I'm going to push it in. It may have a fair bit of back pressure as you get near the end. It's okay. Go ahead and lock it into place. And now we're going to watch on the other side to watch the solvent come out. It takes a while for the solvent to come out. And what you should see is initially a bubble starts to form on the outlet of the line here. That bubble will grow larger and larger as the air slowly pushes it out. Remember that the lines are very, very small in diameter. This is why we need to always have our samples filtered, because it can easily clog the line. The reason they're so small is that we want all of our samples to be up in the coil and not waste very much sample on the way up. What we're watching for here is what it just did, where air starts coming out. So we pushed all of the liquid out, and then it sort of spits out the remaining bits of liquid as the air is coming out. So now the probe is completely empty. It's just got air in it. So we can go to the next step, which is to wash the probe out. And typically what we use to wash the probe out is acetone. Acetone is miscible with most solvents, and it dissolves a lot of different materials, so it's a good...
はい、この度はトロビースキーツアーをご利用いただきまして誠にありがとうございます。
syringe to flush out the probe with acetone, and we typically use deuterated acetone just because it's convenient and relatively clean compared to lab-grade acetone. So I'm going to put on some gloves here. And I am going to draw up some deuterated acetone. Little syringe. Doesn't really matter if there's a small air bubble at this point. Later on, it is important to worry about air bubbles, but for now, if there's an air bubble, it won't affect the cleaning of the probe. So now I'm going to attach this syringe onto the lure lock connection, and I'm going to push the acetone through the probe. Now, there may be a fair bit of back pressure as you push it through. That's normal. Just be aware that if you push really hard, you have the ability to create quite a bit of pressure. You have quite a bit of mechanical advantage here. So what you want to do is push it through so that the acetone comes through at a reasonable rate. You don't want to push it so hard that it starts leaking. If it suddenly gets much easier to push, then you probably develop a leak, and hopefully that is not inside the probe. Just keep steady pressure on it and push the acetone through. It took a while to flush out the system with acetone. So now we flush the acetone through the probe, and we can go back and flush out the acetone with air. We're going air, acetone, air. So we're going to attach the big syringe again. Make sure to remember to draw it up before you attach it. And then I'm going to push it down and lock it into place. And we're going to watch the acetone come out. There you can see the bubble starting to form. And it will slowly push its way through the probe. You can wait until the air has pushed the acetone completely out of the probe. And you can tell because the bubbles stop growing on there and air starts flowing out of the end of the capillary. So we're getting there. Okay, that's it. The air is pushed out the acetone. So now the probe is empty again. It's not strictly necessary, but it's often a good idea to then flush the probe again with whatever solvent that you're using. In this case, we're using chloroform, so I'm going to do a flush with chloroform. So bring your solvent, and as long as your solvent is clean, you can use a syringe, draw up another 250 microliters of your solvent. Acetone has relatively low viscosity, so the back pressure will be less on it. The chloroform has a little bit higher viscosity, so it will have a little bit higher back pressure on it as you push it through. It's going through fairly nicely there. Anytime you're pushing the solvent through, it feels like you just can't push it through, then you probably develop a clog. The clog may be in the filter, hopefully, or in the line, but it's a good idea at that point to contact the shop, and we will try to diagnose what the clog is. This is why it's very important to always filter your samples prior to loading them, because you don't want to ever clog the probe. In this case, things are flowing well, so we'll go ahead and finishing out the flush with chloroform. That may not be obvious, but it's a good idea to push the chloroform out again with air before we actually load our sample. The reason is we don't want to dilute whatever sample is in there, so if the probe is full of chloroform, it may dilute the sample somewhat. So I'm going to go ahead and use air again and push out the chloroform that I just flushed through the probe. we know that the probe will be pretty clean. So once again, going to wait for the solvents to come out and watch the bubble form on the end of the capillary and wait until the air is pushing down and there's just air flowing through the capillary. If you hear the lock beeping as this happens, that's a good sign because that means that you actually pushed the solvent out of the probe and now the probe has no lock solvent in it and there's nothing for it to lock on, so the lock will beep. That means that it's working and that you're pushing out the solvent. You could, if you want, like I said, you could do it a second time. You could disconnect the syringe, fill it again, reconnect it, make sure all your fittings are tight, and then pressurize it and lock it into place and flush things through. I'm pretty sure it's pretty well flushed right now. So now the probe is empty. It's ready for us to load our sample. So to load the sample, we're going to take off the syringe, and we're going to take off this adapter that goes from the filter to the Mueller lock. And we're going to put on a piece that will allow us to load a very small syringe. So this has this green plastic tubing here that a 50 microliter syringe can fit into, and it's going to attach onto the filter. This green part is replaceable, so you can put in a new one. You do want to make sure that it's clean. Likewise, you want to make sure that your syringe is clean before you load your sample. The tip of the syringe and the inlet are probably the most likely causes of contamination from carryover from one person to the other. So you want to make sure all these pieces are clean before you load your sample into the probe. In this case, I'm fairly confident that they're clean, so I'm going to go ahead and load our sample. I have a sample here in a vial. Remember that when you're preparing a sample, it needs to be filtered just like it would for the automation system. You can use the centrifuge filtration method if you prefer. If you have filtered it for HPLC, that's probably sufficient. But just remember that if you concentrated it down, there's a possibility that it is precipitating, and that even though it's clean, if it's precipitating, that could cause the probe. So we want to make sure that there's no particulates in the sample at all, even ones that you can't see. Just because it's clear to the eye doesn't mean that it's clean enough for the probe. It could still contaminate and clog the probe. So this sample's been filtered. I'm going to go ahead and whip it in. If you have an extra sample, you can draw it up, but you need to draw up at least 25 microliters of sample. If you have an air bubble, you need to make sure it's at the top, and if you can, you want to try to get rid of it as much as possible. In the cleaning stage, it wasn't really a problem if there's an air bubble, but in here, if there's a bubble in the middle of your column of sample, that's going to go into the probe and put a bubble into the coil, and that's going to screw up your shimming. So we want to make sure it's free of air bubbles, and again, you want at least 25 microliters of sample. Okay, so now what we're going to do is we're going to put the syringe into the inlet here. You want to push it down until it hits the bottom, and then carefully you want to tighten it. Tightening this connection here will make it so the syringe is sealed, so when you push in the sample, it doesn't come back out. Sample into the probe, and if you have 25 microliters, that should be enough to fill the probe, but not exit out of the this outlet here. If you want to be extra careful to recover your sample, you can put a recovery vial on here at this point. In this case, I'm not too worried about it, so we don't need to do that. So I'm just going to carefully, slowly push the sample into the probe. And if all goes well, we will have filled the probe. And this little piece of tape here to show that we can just keep the syringe there while we run. So you can just put it like that. And it's a pretty thing to do. Your sample can evaporate back through the line. So if you're running for an extended period of time, it's good to put a cap. I've made a cap out of a plug and a union here onto the outlet. Okay, so now the sample is loaded into the probe, and we're ready to go. Okay, now that we've loaded the sample into the probe, we can use Icon and Mark to run the experiment just like you would on any other Bruker and Mark system. And I'm going to show you how to use the automation system, just like we do with the other system. So click on automation and log in with your username and password. And you can add an experiment to folder 1. You'll see that the experiments are all the Captain and Mark experiments. You can do the proton, COSY, HSQC, NOSY. I don't recommend the carbon, but if you really want to, you can do carbon. We're going to do proton here. We should choose a solvent. So we've got chloroform. And you can customize the parameters if you want, just like on a normal system, and put in a title. Okay, next we can submit the experiment and go run, new run, and I'm going to choose the manual lock and shim. quick start. Now we've already loaded the sample into the system manually, but because we're using the automation, it thinks that we need to eject and insert the sample. Just don't worry about it. Just click OK each time. So it thinks that we're ejecting the sample, but we're not. And now it thinks we're inserting the sample, but we're not. So the next step is to lock. Now the lock signal on the capillary NMR is weaker than it is on normal because we have so much less solvent. So after you lock, it is, and this may see that, but it means that it didn't load the standard chips. That's okay. So you can do automatic lock, and it should lock in the normal way. But if the signal is noisier than you're used to, don't worry about it too much. If it's really noisy, then that could be an indication that there's a problem with your sample. Either there's an air bubble in the way or something is wrong. This is reasonable for a core form on this probe, this amount of noise. Okay, now for shimming, I'm not going to cover that right now, but the shimming on the capillary NMR probe is very different than it is on a normal NMR probe because the capillary is oriented perpendicular to the field, whereas the normal NMR tube is parallel to the field. So the main shims that you would use would be y, z squared, x squared minus y squared, xy, and to a lesser degree x and z. So shimming with your normal z and z squared will not improve the shims. Probably the best thing to do is to click RSH and load in the cap NMR shim with the solvent that you're using. And if you want to try to improve it beyond that, you can read the guide on how to shim on the capillary NMR system. In this case, I think the shims are okay, so I'm just going to click shim OK. And then come back to the automation system. It's doing the receiver gain adjustments like normal, and then it's going to go in and start collecting data like normal. Just like on a normal system, if you want to, you can click on spectrum after it's started to look at a snapshot of the spectrum while it's underway. So I will go ahead and do that. And it should bring up the spectrum as it normally is. You should be able to get a data set that looks reasonable. The line width might be a little bit broader depending on your shimming than it is on a normal NMR probe, but you should be able to get under 2 Hz line width. And remember that the capillary NMR probe is less sensitive than a normal probe on a concentration basis, but the volume is much, much less than it is on a normal NMR probe, which gives you the advantage in signal for the total amount of sample. But remember that your concentration needs to be at least as high, and probably twice as high as you would use on a normal NMR probe for the same amount of signal averaging. Once the spectrum is finished collecting, and then it's going to tell you to eject the sample, but again, you can just ignore that. And when you're done, you can stop the run. Yes, you really want to stop. And then you can close. So now it's ready, and your data should be collected just like it is on a normal system, so it should be under your username. And you should be able to double click on it and see the data that you collected. Okay, so we're done here. So the last thing to do is to remove your sample and get the system ready for automation again. Okay, now we're going to try to recover our sample, so I'm going to take off this union. If you want, you can try to wash out anything if it has come out of here, so you don't lose any of the material that might have touched the union. In this case, I'm just going to put the inlet into a vial. I'm going to get the syringe out, loosen it, and I'm going to draw it up with some clean solvent. And you'll want to probably draw up more than the 25 microliters used before. I'm drawing up about 50 microliters here. Put it in and go ahead and push it through. And if all goes well, you should see a bubble forming on the outlet. So now we've recovered our sample. It's a good idea to flush out the solvent that's remaining in the probe. If you want to, you can flush this into your vial to make sure you've captured the last remaining bits of whatever's in there. So I'm going to reattach the adapter that goes to a lure lock. So to reattach the large syringe.